on to today's class, we're looking at polyatomic ions, looking at complex ions, we're looking at compound and molecule. There are collocations or collection of words that is ascribed or used in a field of study. In chemistry, you need to understand that we have the difference between the polyatomic ion, the complex ions, the compound and molecule, so you don't interchange or misplace the use of their words or terms. As a chemistry student, the mentality of chemistry is simple. You need to have the right mental attitude for you to proceed to understand any concept in any field of study. The mental attitude of chemistry is not to be afraid of the symbols of the element and of the formulas and of the equation. What you need to do is to understand the symbols, understand the equation, understand the formulas. That is the right mental attitude. What we're going to do is to explain polyatomic ions first. So, what is polyatomic ions? The first thing is, what is even the word ions? The word ions is simply atoms of elements that are electrically charged. I take it again. The words ions are atoms of elements that are electrically charged, meaning they can have a charge of positive or a charge of negative. If the ion has a positive charge, that is called the cation ions. If the ions have a negative charge, that is called an anion. Alright, let's take for instance, atom of element of sodium. Sodium is neutrally charged atom of element at this time in a ground stage. But when sodium becomes ionized by ionization, it becomes excited and then sodium can lose one electron. Now, this sodium over here is electrically charged because it has a charge. It's a monoatomic ion. It has a charge. Alright? Now, we have chlorine. Chlorine, when it receives an electron, it becomes neutral, it becomes negatively charged, and then it becomes a chlorine ion. Now, this person is known as ion. This is an ion, and this is an ion. This is a cation, this is an anion, because of the difference of charge. Let's come to what we mean by polyatomic ions. Well, polyatomic ions are simply group of atoms of elements that are chemically bound together by covalent bond. I take it again. Polyatomic ions are group or set of atoms of element, two or more atoms of element that are chemically bounded by covalent bond. Alright? You need to know that if I have these atoms of element, this is an example of polyatomic ion. I can also have this. This is an example of polyatomic ion. Well, I can also have this as an example of polyatomic ion. Well, I can also have this as an example of polyatomic ion. Let's choose one of these elements and know the name of each of them. Well, what is the name of this SO4 to minus. We need to know the oxidation number for sulfur. To find that, you need to make sulfur X plus oxygen. Oxygen is -2, and we have 4 molecules or 4 atoms of element of oxygen here. So I'm multiplying by 4, which is equals to -2. -2 times 4, that will give me -8. Remember that we have is equals to -2. If you leave X here, you move -8 to the other side, what you're going to have is +8. Now, there is a -2 already waiting for you down there. -2, your answer now will become X is equals to +8 minus 2, that is 6. So, this is tetraoxosulfate 6. Tetraoxosulfate 6 ion. Not a compound. It is not a compound. Tetraoxosulfate 6 ion, a polyatomic ion. Well, it's also called the sulfate. Notice my spelling. This is sulfate. It is not spelled sulfate. This is wrong. This is wrong. This is correct. It is spelled sulfate. Alright, can we name any of those? Let's pick up any of those. Let's pick up this. Let's pick up this. HCO3 minus. Now, what's the name of this compound? Well, we need to find the oxidation number for carbon. This is, our hydrogen is 1, plus carbon is X, plus oxygen is -2 times by 3. Everything is equals to the charge here, -1. If you do the mass, this becomes 1 plus X minus 6 over there, and then it's equals to -1. Then X is equals to, move 6 to the other side, this is +6 minus 1, move 1 to the other side, -1. So 6 minus 1, that is 5, 5 minus 1, that is 4. So this is hydrogen triazocarbonate 4. Hydrogen triazocarbonate 4. Why is it triazocarbonate 4? Because the oxidation state of carbon is 4. And we have other examples of polyatomic ions. Whenever you see them, you'll be able to identify them. I list them again. Well, I'll give you an assignment to find the name of the ones I'll be listing here. Meanwhile, we have a video talking about, we'll have a video where we'll discuss how to find oxidation numbers. Now, this is a polyatomic ion. We have all done that. Now, this. Now, this. Okay? Alright. No. Let's see this. Okay, I've listed this before. And then, and so on and so forth. Now let's go to complex ions. The next in view is the complex ion. Now, what is a complex ion? A complex ion should have a central metallic atom, and it is surrounded by ligands. I take it again. A complex ion has a central metallic atom of element, and it is surrounded by ligands. Look for this example. This is copper, and this is the ligand ammonia. And then we have this. This is a complex ion. When you see a complex compound, that is not a compound, when you see an equation, a formula, a chemical formula written like this, notice, don't call polyatomic ions compound. They are not compound. Don't call complex ion compound. They are not compound. Call them by their name. These are polyatomic ion. They are not a compound. This is a complex ion. It's not a compound. So you don't interchange, misplace the terms that is used in that chemistry formulas. Now, this is copper 2 tetraamine. Copper 2 tetraamine. Why? Because the ligand over here Copper is X. We don't know that. And then we are going to have 3 times 1, that is 3, times by, this is nitrogen. Nitrogen is minus 3. Nitrogen has oxidation state of minus 3. If you check your periodic table, nitrogen is minus 3. Oxidation number in the periodic table. Now, the nitrogen is minus 3 times 4, and then plus, this is hydrogen. Hydrogen is plus 1. Plus 1 times 3, that is 3 times 4. Alright? So I would say that everything is equal to plus 2. This times this is minus 12. Okay? Plus this times this is 12. Everything is equal to plus 2. Don't forget to put your x. This will cancel out this. So x is equal to plus 2. So this is copper 2 tetraamine. Copper 2 tetraamine. Why? Because the oxidation state of copper in this compound is 2. Alright, let's name another one, another complex ion. The amine are known as the ligand that are surrounding the copper. Let's look at this copper with H2O, and then we have 6 of those in a bracket. Okay, let's say we have a plus 2 here. Now, what's the assignment for today? This is a complex ion. What is the name of this complex ion? We need to know that. Okay, let's find it. If you solve, this ligand supposed to be equal to 0. So that's to make copper a positive 2 charge. Let's try that out. It's not harmful to try it out. We can pause the video and try it out. Anyhow, let's continue. So this is X plus, we have hydrogen. Hydrogen is 2 here. So 2 times 6. So this is 2 times 6 for hydrogen. You see that we have for oxygen. Oxygen is minus 2. Oxygen is minus 2 charge. So minus 2 times by 6. We have one of those, oxygen there, is equals to 0. Now, we have X plus, this is 12, plus X, this is minus 2 times by 6, minus 12 also, is equals to, no, this is not 0, this is plus 2. Alright? You see that? Plus 2. Now, this will cancel this. We have that X is equal to plus 2. We have a video where we do calculation on oxidation number. So this is called Heza. Okay? It's called Heza aqua copper 2 ion. Heza aqua copper 2 ion. Well, let's look for another one, another complex ion. Another complex ion, let's talk about the central metal ion. Let's say we have this ion surrounded by water. Now, you are going to pause the video. You are going to tell me this is known as the name. Let me leave that name for you because we're not going to give you all the names. You need to do your assignment by yourself. Now, I want you to pause the video, or I want you, after the end of this class, tell us the name. Okay? Tell us the name of this complex ion. But meanwhile, you can calculate the oxidation state for the ion there. Alright? Now, we have another one. This can also be this can also be a complex ion. Now, the assignment for you all, you can drop your answer in the comment section. We will know whether you right or wrong, and then we'll give you guidance on how to name this. In fact, you can have 2 names, common name and the common name and also the IUPAC name. Now, we need you to find the name and give us the answer on the comment section. We'll be waiting for you. So let's go to the compound. Compound is very easy. What's a compound? We have a compound. A compound is simply the combination of 2 or more atoms of elements. combination of two or more atoms of element, and then in a definite proportion. Now we have this compound. Let's say this is sodium chloride. This is a compound, H2O. This is a compound, CO3. This is a compound, CaCO3. Sorry, CO2. So CO3 is a compound. All these are compounds. In fact, H2SO4 is a compound. You know why? Notice the polyatomic ion. They have an overall charge that is not zero. Polyatomic ion has overall charge that is not zero. For instance, I told you that this is a polyatomic ion. The overall charge is not zero. The complex ion, the overall charge is not zero. But for the compound, their overall charge is always zero. Now, these are compounds, although they have ionic charge in them. So we can call these an ionic compound because there's a positive and negative charge within it. When you dissolve it in water, you will notice what I'm saying. Now, this is a compound. Take it again. A compound is a combination of two or more elements in a definite proportion. So we go to the next thing, molecule. What's a molecule? Don't forget this one, all of you. Find the name. Give us some installation box. We'll be waiting for you. So we go to molecule. Molecule is the combination of two or more atoms of elements that are covalently bonded. Now, when I use the word covalent, molecule is applicable to non-metals. Molecule is applicable to non-metals. We have monoatomic molecules. We have monoatomic molecules. Monoatomic molecules, we have the neon, we have the argon, which one again? Okay, let's leave it in neon, argon. And lots of them in the group 8 elements. These are monoatomic elements. Alright? Now, again, we want to talk about the diatomic molecules. Now, for the diatomic molecules, they are having two atoms of elements which are covalently bonded together. Now, let's keep an example of this diatomic molecule. For instance, this one can also have helium. Helium is also monatomic. Diatomic molecule, oxygen is diatomic, nitrogen is diatomic, chlorine is diatomic, hydrogen is diatomic. Now, what makes them diatomic? What makes them diatomic is this. Just if you want a video on that, we have chemical bonding, we'll talk about that. Now, you have hydrogen, and you have hydrogen having an atomic number 1, or number 1 valency electron. Hydrogen will contribute 1, hydrogen will contribute 1. This electron is called the shared paired electron. And the shared paired electron will form a hydrogen molecule. And this hydrogen molecule is diatomic in nature. So hydrogen is diatomic. Well, let's do another one. Let's do the one for nitrogen. Nitrogen has atomic number 7, and the outermost shell of nitrogen should have a valency of 5. So we have 1, 2, 3, 4, 5. This is the Lewis structure of nitrogen. And then we are combining it 1, 2, 3, 4, 5. Then these electrons will bond together. I mean, these electron pairs, these electrons will be shared between these elements, these two elements. Now, these contribute an electron to this contributes an electron to this, so that they can be stable. Because for an element to be stable, it must have an octet configuration in the outermost shell, or you have a duet configuration, you have a duet configuration in the outermost shell. This already has a duet configuration in the outermost shell. It's something like this. So these two for here, these two for this one here. So it's a duet configuration. Now over here, the nitrogen will now become 1, 2, 3, 1, 2. Alright, so this is here has 6 electron maximum. 6 plus 2, that is 8. 6 plus 2, that is 8. And nitrogen is triple bond. Nitrogen, if I ask you, what's the bond of nitrogen? It's triple bond, because you can see the bond that forms the nitrogen molecule, which is diatomic in nature. I want you to find the bond. How many bond that is in hydrogen? That is 1, just 1 bond. Hydrogen has just 1 bond. Alright? Find how many bond that is in oxygen. And then we're waiting for your answer on the comment section. This is all we've got for you in this video. We're going to see you in our next class. Bye for now.